Welcome to this walkthrough video of our Swift text-to-speech web app. Let's dive into the code and see how it functions, section by section. We kick off with our imports, Vapor, Leaf, and Foundation, which provide us with essential functionalities for our web app, like handling HTTP requests and parsing data. First up, we're loading environment variables using a custom function, load.env. This function checks for a .env file in our working directory, reads it, and sets each key value pair as an environment variable. This is crucial for managing sensitive information such as API keys without hard coding them into our app. Next, we have a couple of global helper functions, notably nenvar, which retrieves the value of environment variables. Here, we extract keys specifically for OpenAI and in-world API, which are necessary for our application's operation. We also define important directories for our app, like where to store audio files and where to find the question history. To manage history, we introduce load history and save history functions. These functions handle reading from and writing to a JSON file that tracks past interactions or question histories. This helps in providing continuity in user interactions over multiple sessions. Moving on to a utility section, we have a shell helper function. It allows us to execute shell commands directly from our Swift code, capturing their output or raising errors if they fail, which can be useful for various back-end tasks like file manipulation or system setups. We then see a function, split sentences, designed to split given text into individual sentences. It scans through the text and separates it based on punctuation marks. This is particularly useful for processing text into manageable chunks for text-to-speech conversion. The Fetch In-World Voices function makes an async HTTP request to retrieve available voice options from the in-world API. It handles authorization, fetches the data, parses it, and returns a sorted list of the available voices, favoring certain voices like Cedric by placing them at the top. We also define in-world TTS, our text-to-speech functionality that posts text and voice IDs to the in-world API, retrieves the spoken audio in a base64 format, and converts it to usable data for our app. For AI-generated text, the OpenAI chat function interfaces with OpenAI's GPT models by sending prompts and retrieving AI-generated responses. This interaction is crucial for driving dynamic and conversational elements of our application. Finally, the Generate TTSA audio function handles converting longer text inputs into audio. It splits long texts into smaller, more manageable sentence-based chunks before processing these chunks through our TTS service to generate concatenated audio files. With these components working together, our Swift app efficiently handles the interaction between text, AI-generated content, and synthesized speech, creating a seamless and interactive user experience.